Good morning students. Welcome to Sunay Sir's online classes. In this video, I am going to explain you total internal reflection and some of the examples of total internal reflection. First, let us see what is total internal reflection. Let us consider a situation where light ray is traveling from denser medium to rarer medium. For example, if there is a water and if light ray is traveling from water to the air, and this is the normal to the surface, and when light ray is traveling from water to the air in this way, this light ray will bend away from the normal. Instead of going straight like this, it will bend away from the normal. Now whenever you increase angle of incidence, when angle of incidence is increased, then angle of refraction also increases. When angle of incidence is increased, angle of refraction also increases. It means at some angle of incidence, if you go on increasing angle of incidence like this, at some angle of incidence, angle of refraction becomes 90 degrees. Angle of refraction becomes 90 degrees. So at this case, this angle of incidence at which angle of refraction is 90 degrees is called critical angle C. The angle of incidence at which angle of refraction R is equal to 90 degrees, that angle of incidence is called critical angle C. So whenever light ray is traveling from denser medium to rarer medium, so when you increase angle of incidence, angle of refraction also go on increasing. At some angle of incidence, angle of refraction becomes 90 degrees and refracted ray will move along the surface. Instead of entering into the denser, instead of entering into the rarer medium, this refracted ray, it will graze along the surface. It means it will move along the surface. So this angle of incidence is called as critical angle C. It is called as critical angle C. The angle of incidence at which angle of refraction is 90 degrees or refracted ray grazes along the surface. It means refracted ray moves along the surface is called critical angle. According to Snell's law, we know that N2 by N1 is equal to sin I by sin R. So at critical angle, I is equal to, at critical angle, I is equal to C and R is equal to 90 degrees. And N2 is second medium is, if we consider it as air, second medium is 1, and N1 is equal to, let us take it as refractive index of first medium, that is denser medium N. Now if we substitute these values in the formula, N2 is 1 and N1 is N, that is refractive index of denser medium, and sin I is equal to C, and sin R is sin 90. We know that sin 90 is 1. So 1 by N is equal to sin C. So from this we can conclude that sin C is equal to 1 by N. So at critical angle, sin C is equal to 1 by N, where N is the refractive index of denser medium. N is the refractive index of denser medium. So this formula is very, very important. I want you to remember this formula, sin C is equal to 1 by N. Now let us see one example. Find the critical angle of medium whose refractive index is given as 2. Refractive index of the medium is 2 and we need to find critical angle, that is C. We have one formula, that is sin C is equal to 1 by N. And N, refractive index of the denser medium, is given as 2. So sin C is equal to 1 by 2. So from this, if sin theta is equal to 1 by 2, then theta is 30 degrees. It means C is 30 degrees. So answer is critical angle is 30 degrees. Let us see one more example. Find the refractive index of benzene whose critical angle is 45 degrees. Here medium is given as benzene and critical angle of the benzene is given as 45 degrees. C is equal to 45 degrees. We need to find refractive index n. We know that sin C is equal to 1 by n. It means from this sin 45 is equal to 1 by n. Sin 45 is equal to 1 by n. We know the value of sin 45. Sin 45 is 1 by root 2 is 1 by n, and from this n is equal to root 2 and its value is 1.414. So finally refractive index of benzene is around root 2, that is 1.414. This is how you need to solve the problem. Now let us see what is total internal reflection. When light ray is traveling from denser medium to rarer medium, and angle of incidence is greater than critical angle. For example, if light ray is traveling from water to the air, it means when it is traveling from denser medium to rarer medium, and if angle of incidence is greater than critical angle, I is greater than C, then light ray instead of going into the rarer medium, it will reflect back into the same medium, it will reflect back into the denser medium instead of going into the rarer medium. This phenomenon is nothing but total internal reflection. So for total internal reflection there are two conditions. First condition is light ray should travel from denser medium to rarer medium, and second condition is angle of incidence I should be greater than critical angle C. In this case light ray will not enter into the rarer medium, whereas it will get reflected back into the same denser medium. This is called total internal reflection. And in daily life we can see lot of examples for total internal reflection. They are some of the examples of TIR are shining of diamond, twinkling of stars, even it is because of total internal reflection, and coin appears to be raised up when it is kept in a vessel of water. This is also because of total internal reflection. Fish appears to be raised up. This is also because of total internal reflection. Formation of mirages and optical fibers. All these are examples of total internal reflection. Now I am going to explain you how optical fibers work based on total internal reflection and how diamond shines because of total internal reflection. Shining of diamond. We know that diamond will be cut into precise shape somewhat in this way. So when light enters into the diamond, whenever light enters into the diamond in this way, this light, because of precise cut of the diamond and because of sharp cutting of the diamond and because of high refractive index of the diamond, you know that from the previous videos refractive index is highest for diamond and that is 2.42. Because of this high refractive index, and because of sharp cuts of the diamond, the light ray will undergo total internal reflection as critical angle of the diamond is very low. Critical angle of the diamond will be very low. So whatever the light ray hits the diamond, it will undergo total internal reflection and it will undergo multiple number of reflections in this way, like this, inside the diamond, and after undergoing infinite number of reflections, at some point this light ray will come out. Because of this infinite number of reflections, multiple number of reflections, diamond will shine like anything. So the basic reason is because of very low critical angle of diamond. For diamond, critical angle is very low, that is around 24.4 degrees, and this low critical angle is because of high refractive index and sharp cutting of the diamonds. So when critical angle is very low, at whatever the angle light enters, it will undergo total internal reflection. It means critical angle is very low, 24.4 degrees. So when light enters at 30, 35, 40 degrees, 45 degrees, so at whatever the angle light enters, it will undergo total internal reflection, and there are high chances of light ray undergoing TIR, and it will undergo multiple number of reflections inside the diamond, which makes it shine. Now let us see very important example, optical fibers. So optical fiber is very thin fiber made of glass having radius, sorry, not radium, it is radius, very thin glass. It is made up of glass and it is a very thin fiber having a radius of micrometer. Around its radius will be micrometer, it means around 10 power 6 meters. Radius of optical fiber will be very low, it means it is a very thin fiber whose radius is around 10 power minus 6 meters, that is around a micrometer. And bunch of it means set of such thin fibers is called a light pipe. In this image you can see, this is, each fiber is nothing but a optical fiber. It is a very thin fiber whose radius is around 10 power minus 6 meters, that is in the order of micrometer. And all these set of such thin fibers is called light pipe. It means it is used to transmit light signals. So this optical fiber is used to transmit light signals. It is mostly used to transmit communication signals. First, electrical signals are converted into light signals, and these light signals are sent into the optical fiber. So because of very small size of the optical fiber, light going into the fiber makes critical angle. So because of very small size, these optical fibers are used to transmit communication signals and light signals. It means nowadays we are using mobile phones, we are talking with our friends and relatives who are on the other side of the globe. This is only because of transmission of signals through optical fibers. It means all the signals, electrical signals, whatever we talk, they are converted into light signals, and these light signals are sent into the optical fiber. Because of very low critical angle, this light signal will undergo total internal reflection in the optical fiber, and this light signal will travel throughout the optical fiber because of total internal reflection. Inside the optical fiber, these light signals will undergo number of reflections, and throughout the optical fiber, throughout the length of the fiber, this light signal will travel, and it will come out of the light signal at the end of the pipe. It means we are transmitting this signal without any loss of energy. Whatever the light we are transmitting, it is going to the other end without any loss of energy. Hence, total internal reflection takes place and light ray travels throughout the length of the fiber without loss of energy. These signals are retrieved at the end of the pipe wherever it is needed. At the end of the pipe, wherever it is needed, these signals, whatever it may be, communication signals or internal signals, internet signals or mobile call signals, all these signals will be retrieved. It means they will be decoded at the end of the pipe, at the end of the optical fiber. So if you want to send these signals through air or any other means instead of optical fiber, then there will be lot of energy consumed, lot of energy will be consumed, and there are high chances of loss of signals in the air, and there are high chances of signal distortion. It means sometimes we will listen the voice of other persons, and sometimes there will be missing of signals when we call to our friends or relatives. So this is because of signal distortion. This type of cases will be occurred when signals are transmitted through air, whereas if the signals are transmitted through the optical fiber, there is no chance of loss of signal at all, and there will be very good quality in the signal, good quality and clarity in the signal. Another use of optical fiber is in the scanning purposes. Usage of optical fiber in scanning purposes. Organs like intestines are not visible to naked eye. They are not visible to human eye, we know. Hence, in order to see those organs, doctor inserts a set of optical fiber. He will insert 2 optical fiber into our body. In order to see inside parts of our body, doctor will insert 2 optical fiber to our organ. So through one optical fiber, doctor will send a light, and this light, after going into the optical fiber, because of total internal reflection, it will undergo number of reflections, and it will travel throughout the optical fiber, and it will fall on the organ. As a result, organ gets illuminated. It means this organ will get lighted up, and this light whichever coming from the organ, it will fall on the another optical fiber, and this, after falling on the another optical fiber, this light will undergo total internal reflection. It will undergo multiple number of reflections, and it will travel throughout the optical fiber, and it will reach the end of the optical fiber, and this end of the second optical fiber will be connected to the system or computer, and in this computer we can see image of the organ. Here we can see image of the organ. In this way, doctors uses these optical fibers to see the inside parts of our body. Through one pipe, light is sent inside the body, and light falls on organ and will be illuminated, lightened. The light which is reflected from the organ enters another optical fiber and travels through the fiber and reaches computer, which gives the image of the organ. In this way, optical fibers are used in scanning purposes. I hope it's clear. Thank you for watching the video.